So here we are. This is going to be the second code clinic, and we're going to be extending on what we talked about 2 weeks ago, which was Git and some basic ideas of Git. So this code clinic is going to be a lot more informal. I'm not going to have a presentation to go through, and I'm going to co-host it with Ben. So the workflow of the session flow is going to be, we're going to touch on the second example from my presentation 2 weeks ago and get through that. That was using a command line to do Git commands, and we're going to play around with that Git repository we set up 2 weeks ago. And then Ben is going to do a few intermediate GitHub commands. He's going to use some of that functionality like GitHub actions that we talked about to do continuous integration and sort of make your repositories more higher functionality. And then we're going to talk a bit more about branching and pull requests and swapping data between different repositories. So that's the general plan. And I suppose the first thing to do is to ask if anyone has questions pertaining to the last code clinic or Git questions on that first talk I did. If not, we'll just carry on to the example. Let's carry on to the example.
I'll keep an eye on the group chat in case if someone wants to put their question in there.
Sweet, that sounds good. So I'm going to share my screen with everyone. So here we go. Okay. So everyone should be able to see my desktop, which has the browser on the left side and a terminal screen on the right-hand side. Yeah?
Yeah, looks good, man.
Okay. So what I wanted to do in this example was to interact with that GitHub repository we made via the command line. And so everyone 2 weeks ago would have made their own GitHub repository of that Git demo. Can everyone bring up their own version of that GitHub repository now, just so you can have this URL link, which is up the top there?
Hey, Jules, is it possible to increase a bit the size of the font?
Sure, good
and
point.
The terminal.
The terminal, definitely.
Yeah, because, yeah. Nice, much better.
Julian.
Yes.
I was teaching a couple of weeks ago and I missed that. So would you be able to just very quickly in 10 seconds tell me what I need to do?
Okay, so go to this URL up there. Can you see that? Do you want me to send it to you?
Can you paste it in the chat?
Done.
Because you're so wonderful. Thank you, buddy.
Okay.
Oh my God, you make our life so easy.
So then you're going to go there, and I assume you've got a GitHub account all set up, Sabine.
Yep. Yep.
So once you're there, you're going to hit this fork button on the top right-hand side, and that's going to make a clone of my repository to your repository.
Nice. Okay.
Your GitHub account, my GitHub account to your GitHub account. Once you have that, then you're basically where everyone else is.
Okay.
What we did last week was we made a fork of my repository, and then we started making changes via GitHub to everyone's own repository. So you won't have those changes. You're going to have the original version of the code, my code, but that's fine. You can still carry on this this example.
So should I download this to my computer, right?
So that's what we're all going to do now.
Okay, all right.
So I'll go back to my slides. Oh, I need to put them in present mode. Yep, that's fine. So this was, we called this the Git command line foo.
Slides. I've just pasted the link to your slides in the chat in case anyone's looking for them.
Good point. Good point. So what we're first going to do before we interact with our GitHub repository is we're going to open a terminal and we're going to make sure that Git is correctly configured on our terminal. Right? So this is the most fundamental step, because if you don't get this right, then you won't be able to use Git to interact with the GitHub account that you've set up. So the first thing that I want you to do is just make sure that you've got the Git configured correctly. So what you can do is run Git Config -L. And I'll show you what that looks like on my screen. Git Config -L. And I get back a bunch of information about how my Git account, or how my Git program on my computer is set up. And the most important line is that I have my email and my name assigned to this user.email variable and user.name variable. So I hope everyone can try this Git config -L and see those results.
Yep. I guess this is related, maybe we covered later, but one of my questions was that tied to my email, I have like a public facing, like personal GitHub account, but also the enterprise GitHub account. So maybe later we can talk about how to work with different accounts. Or...
Yeah. I don't actually have too much experience with that, but okay. Yeah, let's bring it up.
It doesn't have to be covered, but I was just curious if other people were doing similar things.
Sorry, why would you have different accounts? I didn't get that.
Julian, the reason for me was that back in the day, a few years ago, Sydney Uni didn't have an enterprise account, right, with GitHub. And so I had just a normal GitHub account with my Sydney Uni email. But then they also released like an enterprise version, which is also linked to my email address through my uni key, right? And so the enterprise version seems to be what generally internal only, whereas the kind of public facing is out there. Does that make sense? Is that, Ben, is that?
Yeah, so I think for the GitHub enterprise, it's probably just best practice to have the university email account on there, because I think for all intents and purposes, if you're working with your own private repository, it doesn't really make a lot of difference. You can still commit to your own repositories, kind of no matter what sort of email address you configure Git with. But I think the enterprise version of Git will require a university email. Yeah, so it's probably best to use your UCID email for this. It's also worth pointing out that you can change the email, the user email on a repository basis. So if you have one repo that's your personal one and one that's your university one, you can have different configurations for each one.
Cool, thanks.
So a lot of people will have a blank user.name that comes up in there git config -l. So that means that you haven't configured your Git client. So if you want to configure your Git client, you just type in those commands that Jules put on your screen, which is git config -- global user.name, and then your name there. And then you should have something in those fields if you go git config -l again.
Ben, can I just clarify the message that I wrote before? I didn't mean that my username has nothing in it. My username has my actual name, first name, last name, with a blank in between, i.e. like a non sort of Unix compliant way of...
Ah, yes. No, that's fine. Yeah,
Good.
That's okay.
Okay.
Yeah, the real reason for setting up these variables is just that when you make a commit, it stamps your name and your email attached to that commit. So when people later down the line look at the repository history, they see, you know, who's to blame for making that commit. As for the authorization for committing to a repository, that's done on the per push basis. So every time you make a push, and a push is where you copy something from your local machine to a server, that's when you need to have authorization for that repository. And that authorization can be independent of the username and the user email you put in these fields.
But guys, also, I mean, since you can put anything in here, I mean, you can say you're Steve Jobs, right? Isn't that a bit weird that it's not actually verified through an email address?
Yeah, you could. You could. And then you're getting like Steve Jobs at a rubbish email committing or pushing to servers. But that's the history of GitHub. Yeah, why you would have someone doing that?
You could have the real Donald Trump.
Yeah, but I mean, you know, I mean, it sounds like a pretty significant flaw. You know, somebody could put in malicious code. You know, if you're not reviewing the changes.
No,
like
they don't have access to the repository necessarily, right?
You can make a private repository that no one can see, or a public repository.
I know, but like if you have a public repository that you want as a community infrastructure, and I mean, you said
you can't commit by default on public repositories. You have to be invited to that repository to be able to push there.
Okay.
Yeah. So you can view everything that's public, but actual pushing to the repository, that's gated.
Okay. Cool.
So now that we've set up our Git client, we can move on. So let's pull down our repositories to our local machine using the Git client. And so the first thing we're going to do is run a Git clone on the URL of our repository. So all we need to do is get our URL for the repository, which should be in our browsers on GitHub. So I'll take you through those steps. So my URL of my GitHub repository is going to be up here, and I can get it by copying and pasting this line. Or even better, I can click this big green button that says clone or download. Once I do that, I get this URL here. I can hit copy. Boom. And then I'll just go to my home directory, clear my screen. So I'll make sure this is a fresh looking directory. And then I'll run the command, which is Git Clone and my URL address. So I'll give you some time to orchestrate all that in your terminal window. When I hit enter.
Are we cloning your repo or the repo that we have in our accounts?
The repo you have in your accounts.
Okay, cool.
So what that means is my username is Jules G Hub. You won't have that in your accounts. You'll have whatever your username is. So when I run this command, I get Git telling me a lot of diagnostics about how the clone is going. Cloning into Git demo, blah, 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 boom, boom, boom. And then it just takes me back to the terminal. Now, if I do an ls in that directory, I should be able to see my repository, which is called Git demo. So I'll do ls Git demo, oops, one word, Git demo. And there it is. I have my repository pulled down. I've done a clone. So what this means now is we've got two repositories. We've got our local repository, which is on our machine, and we've got the GitHub repository, which is on the GitHub server. So let's make some changes to the local repository on our hard drive, and then we're going to push those changes to the GitHub server. So a change we could make is to the README file, for instance. So the README file is just a markdown file. You can see by this MD here. And I could make a change by just opening it, editing some lines, and then committing that to my local repository. So does anyone have any questions at this stage, or can I go ahead and edit my README file?
Hey, Jules.
All good for me.
Jules, it might be good to maybe open that up in a folder. Just, I think the command line might be a bit unintuitive. Some. So yeah, if you just bring it up in File Explorer, then
wow.
It looks more familiar. You got a lot of files, man.
I got a lot of files. Sorry. You know what I'll do? Maybe I'll make this cleaner. No, I won't. You can see that I've got a big dump of all the files in my home directory, and I've got one. That's a bit more magnified, but I've got the Git demo sitting here. And underneath that, I have my files. Yeah, and so carrying on with the editing the file, I can just open the README with a text editor. Whoa, that's a big text editor. I can just make some changes to the README file. For instance, I could change this demo repository to something title. Dun, dun, dun. Now I could save this file, save it however you need to. I think it's Control S for me. Excellent. And now let me go back to my command line. And now we're going to see how Git registers this change in the file. I got to write a few weird commands. Don't worry about these. This is because I opened a Windows file directory viewer. But let me just stop that. Okay, good. So how I'll use Git to see the changes to the files, I'll go into the Git demo directory. So cd git demo. And then what I'll do is I'll run this command called Git Status. And Git Status is much like an SVN status. You ask for the status of the version control system currently. And so with my change, Git Status should report that something has changed from the version control that it just downloaded from the clone step previously. So after I ran the Git Status, it said, there's been a modified file, which is the readme.md, which we see in red. We can go further and ask Git, what exactly is that change? Because it's just saying there's a changed file. We could ask Git, tell us what that change is. And we can run a command like Git Diff, which tells you the differences. So I'll write that, Git Diff. If I hit enter on this, it gives me just a Unix diff of the README file, which is quite ugly, but it tells you the pertinent information. It says we got rid of this line and we added this line. And that's it. So that was a big bunch of command line. Does anyone have any questions on that?
So, Jules, I have a question. What if the file that you are changing is not a text file? It's any other file that you could, there's no way for you to see it here in with this Git diff.
Yeah. So CVS files, for example, is just data thrown into cells, but the cells are usually just delimited by some ASCII character. So it appears much like this Git diff. So if you're changing something like a CVS file, which is run using ASCII data, it's very similar to this diff that you'll see. But if you do something like an image or a binary file, then you get a lot of junk printed to the screen if you use Git's client for the terminal to visualize the diff. Because the command line only prints alphanumeric characters to the screen. It can't really handle image files or binary files or things like that. Later though, Ben is going to show us a neat little trick for image files. Does that answer your question?
Yes, it did. Yeah.
Cool. Okay, so while we're at this stage of using Git to inspect our repository status, I want to highlight a few more interesting things that Git you can use Git for to look into the repository. And I've put these on the slides, so I'll just revert back to the slides, so bear with me. That's what they were. Good. I forgot my own notes. So the first command I wanted to show you was git remotes. Git remote -v. This tells your Git client to say which other repositories it's connected to. So this is important because I'd like to know if I do push and pull commands, which other repository am I doing those push and pull commands to and from? And as I mentioned in the 2 weeks ago, Git doesn't have like a central repository that is preferred. You can have as many repositories as you like to push and pull from. And the thing is, you give them all weird and wonderful names. But in this example, we've only got the GitHub repository that is acting like our origin. And because I've only configured one repository, you can see that after I've typed in this git remote -v command, it just says origin, and origin equals the original GitHub URL. But I could add many remotes here, and I could give them all funny names like Ben's repository, Daniel's repository, Dietmar's repository, and I could refer to all of these GitHub repositories if I wanted to push and pull to those repositories. So that's something I wanted to raise as kind of the idea of GitHub being a distributed version control system. That's the way you can inspect your remotes and where you're actually pushing and pulling code to. Another command that is quite familiar to people that would use SVN is Git Log. So if you type in Git Log in your repository, it's going to give you a log of all the change sets that has come previously. So when I hit Git Log, the terminal is going to explode with information. So here we go. And this gives me a rundown of all the commits I've made to the repository in the past. It tells me a few important things, some of which we touched on previously, which was the commit ID. Commit IDs are this awful SHA number, which aren't as simple as SVN's sort of indice values, but this is how you refer to commits in Git. It tells me the author's name and the author's email address. These are the things that are populated from the Git Config variables we set up just at the start of this presentation. It tells me when the changes were pushed to the repository or when the changes were committed to the repository or pushed. And it also shows the commit message, which I made when I made that change. So for everyone else, when you run a Git log on your repo, you shouldn't see my name as the last commit. You should see your name as the last commit. Has anyone got any questions about that? And finally, the last command I wanted to go through is to get back to an old version of our code. So say we've made the last commit, but we want to go back to 2 commits previously. If we want to do that, the way we can is to run a Git Checkout command. And that is as simple as Git Checkout. We find the Git ID that we want to use, the commit ID. In this case, it's going to be my second last one, which is this very long string. I can copy that long string and just paste it in behind my Git Checkout command. I could say Git Checkout to that. In truth, you don't actually have to use these really long names. You can do more simple stuff. Oh, someone's written a big message.
Sorry, that was just me. Just ignore it for a moment. I do have a question related to it.
Okay. Cool. Cool. So
I have a question too. So yeah.
All right. Well, I'll hit mine and then we'll see what happens. Ooh. I got in a funny state. So I got in a state where Git has detected that I've made a change to a file and it won't let me go back to a previous state because it's saying, you've made a change. What do you want to do with that change before I go back to a previous state in the repository? And this is where you have to be very careful with how you use Git and how you take care of your files, especially if you want to go backwards in history or forwards. You have to remember, like, you have to make sure the files are all in sync with the changes as the history of the Git repository demands. Otherwise, Git just won't allow it. Right, the questions.
Yeah, sorry. My question was that, so I followed that and I did Git Checkout and used one of those earlier ones from, from you, and it says you are in detached head state. You can look around, make changes, blah blah blah. So it seems like it's undoing the branching, the forking, right? Or I don't know what it's doing here.
It's fine. What you're going back to is an old state of the repository, and that's exactly the command you always will receive. And this is one of the big things I really don't like about Git. When you go back to a previous version of the code, you get this emergency detached head state. And you think to yourself, oh, what the hell is this? Because
it's decapitated.
It's decapitated. This is A-OK. Let no one scare you. Git has a preference for always working on named branches. Named branches is what it calls a head state. Now, I'm not 100% sure if I'm describing this correctly, but one thing you will notice is that Git likes to call branches names, likes to have a name for a branch, like master. That's your normal branch, and you always have to make names for branches. And so all Git is telling you when it's in a detached head state is that your named branch, the tip checkout of that branch, is some commit that has a name associated with it. And every other commit behind it does not have that name associated with it. So when it says you're in a detached head state, it means that you're not on the commit with the named tag pointing to it.
So then to go on from this, do I do a git checkout -b and change it to master? Or I mean, I don't understand what I need to do now. I just do
Yes.
git commit.
So you can do a git checkout -b and a new branch name.
Okay.
And that will cause a new branch to be formed. Do you want me to bring up a diagram of what this all looks like?
I don't know what maybe see what Julian has terms of
Sure.
question. I don't want to be taking up your time.
Sure. Okay, Julian, do you have a question too?
Yeah. So when I type the I forgot that the Git log command. So I got the commit from the 1st of April, and then two from the 1st of April, and one from February the 18th.
Yep.
But then I'm seeing I can see your terminal, and you have more than that. So you have another one from that date, from the 18th February, and then another one from the 17th. So why I cannot see those commits in my terminal, in my log?
Perhaps.
Well, if it's relevant, like it's just like.
I think you should be able to see all the history. Maybe when you did a git log command, you exited git log. When you hit Q, it exits git log, and maybe you just didn't keep on scrolling down. Yeah. So if I enter git log again, I hit enter. If I hit up and down, I can go back in history a lot, and then I'll hit Q to exit.
Yeah.
I can see that you made the initial commit on Valentine's Day. That's very romantic.
Yeah.
It's the right time to commit.
That's brilliant.
That is such a dad joke. It's not funny.
It's so funny. It's very good.
All right. So just to, yeah, I'll just show this image. So Sabine, the idea you found when you're in a detached state, let's pretend this C3 does not exist in this diagram, and I'll use this diagram to explain.
Okay.
Git always likes to have a named head of a branch. And so in this case, C2 is our commit, and its name is master. So you could always do git checkout master, and it'll take you to C2. But if you go git checkout C1, whatever C1's commit message is, Git is going to tell you, oh, I don't have a name for that. I don't have a name for that commit message, and therefore it's not a head. So you're in a detached head state. And
my God.
All the detached head state is a commit without a tag, essentially.
Okay. But is there a way now then, because, you know, say C2 was a mistake, and I've checked out C1, and I want to make C1 now the master.
Yes.
So
let's do it.
Okay. Oh my God, this is so exciting.
Reset hard.
Whoa.
Hey.
Reset hard. Okay.
And you go git reset hard, and you find the commit ID that you want to revert to, which I think is AB5E5 blah blah blah. And if you hit on that, you will be doing what you've asked about by reverting back to the C1 change.
Okay, that's actually handy.
I'm glad something was. Okay, so essentially, there were some good questions there. The git reset hard, I'll bring, yeah, that's a good trick to remember because Git really likes to make sure you're always keeping files in check with how the repository can handle making modifications. And so as I brought up, that head state, a named commit, is really important to Git. So the reset hard lets you strip off all the commits that occur after a change, and so you effectively reset to the commit ID you want, and you reset the head label. That is confusing. Sorry if that confused everyone. Okay, so there's one last thing I wanted to show you in this example, which is in this Git demo, we changed a few things. We'll do a Git status to review what's going on. Okay, we modified the README file. And how did I modify it? I can do a Git Diff. You can see the changes I make. If I'm happy with this, I can then do a Git Commit -am, and I can put a Git message in here, like new title change. I can hit commit, and all this does is commit to my local machine, my local repository. Excellent. So that commit has gone through. Now if I do a Git log, I should see this new message and the new change set, which is going to start with EBA for something or other, in at the top of my Git log command stack. So here we go. Sure enough, it's up there. And this is where we see some interesting ideas. So I'll just go through those interesting ideas. We see that there's this change set and it says head is master. Okay, that's referring to my local repository on my hard disk. The head pointer is pointing to the master on the local machine, and master is just the name of the current branch I'm working on. I didn't reveal branches. While I've got you there, bear with me. I'll show you which branch we're working on and how we can find that out. I'll just quit this screen and I'll run git branch. This will tell me which branch I'm on. This is a central idea to Git, so you need to just know about how to see the branch. If I run git branch, it tells me I'm on the master, which is the default branch. So everyone will be on master for now because it's default. So back to Git log. It tells me the head is pointing to my master branch. But on the second commit down, it tells me this commit is where origin master is pointing to. And origin master refers to that origin repository, the other repository that I'm pushing and pulling to, which is the GitHub repository from where I cloned this repository to my local machine. So Git is able to pick up that now I am one commit ahead of my repository on GitHub. Is everyone okay with that?
Yeah, I mean, that all makes sense because I've done the whole headless decapitation thing. I get an issue that it says changes not staged for commit. I mean, I don't understand why I need to restage everything. I mean, it seems very clunky. Do I just have to do the git minus a?
Did you minus AM?
No, just minus m.
No, you need to do AM.
Okay, but why do I need to re-add it or restage it when all I've done is gone?
You have to stage every change. You have to stage changes because I don't actually have a succinct answer for you. It's to do with the fact that you have a local repository, but you also have the changes on your hard disk that might differ from the local repository. So you need to tell the local repository to pick up those changes.
So Ben, say if you have you're working on multiple files at once, and you might want to just commit a bunch of changes to only a select few files, then you would only stage for committal those files that you want to be that you want to actually commit. So yeah, so you can actually like pick and choose which files you want to commit.
Okay, that's actually that explains that. Yeah, because I mean the SVN GUI, I can just select which files I want to commit. I don't have to commit all of them. But does the minus AM then commit stage all of them?
That's correct.
Yeah.
Yes, everything that's already been added to the being tracked by Git, by doing the minus A, that commits everything that's changed to all of those files.
That is a great explanation, guys. Thank you so much. Wow.
Nice, Ben.
Should we get on to CI, or we're kind of running a bit low on time?
Oh, wow, we're running very low on time. Sorry, Ben.
That's all right.
My fault.
Having so much fun.
Sorry.
I think what we should do, if everyone's got this this change on their master, let's just commit that to our GitHub so we can see it, and then we'll talk about what we'll do next week, or what we can do in the final moments. So I'll get rid of this Git log. So my Git status reports that I've now got I'm on master branch, and my branch is one ahead of the origin master, which we know is the GitHub version of this repository, by one commit. Use git push to publish your local commits. So I'm going to run git push, and it knows that when I do this push, I'm going to push it to the origin, which is default. If I have multiple repositories set up as remotes, I can specify them. But I'm just going to run git push, and I'm going to push these changes from my local repository to GitHub. And here is where it asks for my authentication details to access and make changes to that GitHub repository. So I'll put in my credentials. And there I get Git telling me a bunch of diagnostics from that push. So hopefully everyone can make a commit like Sabine just did, and then run a push to their origin repository, and your origin repository should be your GitHub repository.
Perfect.
Yeah. So I'm happy to answer questions about that, or we move on.
I might just quickly go through some of the nice diffing stuff with GitHub.
That sounds great, Ben.
Yeah. So, unless if anyone's got some quick questions for Jules. I can share my screen. Okay, I'm going to share my screen. Okay, can everyone see that?
Yep.
Yes.
Awesome. Yeah, so this is probably something that you'll see on your version of the repo on GitHub. So yeah, instead of Jules Hub, you've got BR Mather there because that's me. Yeah, so we've got a whole bunch of files here. Now what I've done is I've actually created a few changes to the repo and committed them. So we can look at those changes if we click on commits, and we can see a whole bunch of changes that I've made and that Julian's made because we've forked his repo. We can also see these changes if we go Git Log in the terminal, and we can see the same changes just represented on the terminal. So say if I want to go back to the last change that Jules made, which is here, update to README, I can scroll down here. Wait, is that? That's me. That's Jules here. So I can just copy this commit hash. And then if I go Git Checkout and then paste in that commit hash, then I go back to that version of the repository. Notice that some of my files have all disappeared because they didn't exist at that point in the repo's history. We can also do the same online on the GitHub website. I can go back down to here, and this little button here says browse the repository at this point in history. And so that takes me to an exact spot in the history, which matches my current repo on my local computer. So that's all very nice. If I want to get back to that, I can just hit back a few times here and take it up to the present day. I can also go back to my terminal, go checkout, Git checkout, just go master, and then we can see my files have returned to me, which is good. And so what I have done is I've actually added an image in my repo, and this is a picture of a younger Dietmar and Joe Whitaker. And what I've actually done is I've edited that image. So if I click on the file here on the GitHub website, Dietmar and Joe, it'll show me that image. What I can do is demonstrate some of Git's rich history comparison. So this is rich diffing. So if I go on history here, and then select which point in time I want to compare it to. So I'll do this one. It's shown me that how much of a file change, how much of a change to the file size there's been. So a decrease in 42 kilobytes. This doesn't show you much, but if I go on display rich diff, we can see a side-by-side comparison between the old file and the more recent file. So this is showing the old file and the more recent file. We can also do a swipe. So I can drag the slider and you can see what's happened to the person in the background. It's basically just been erased. So I don't know who that is. It's probably Nico Flament or something like that. We can also do onion skin, where it just gives you a nice slow fade in and out. So that's pretty nice, and that'll become relevant for Earthbite probably when we have rich diffing of, say, age grids, where you can see what your change to the plate reconstruction might do to the age grids, and then you can compare the more recent version to a version in the past. We won't actually show you that sort of example for now, because we're pretty much out of time. But say if I want to, so I'll do Git status in the terminal again. Okay, so I'm up to date with master. Say if I want to do some more changes to that file, I can open that in my favorite image editor. I can add some text. Let's say we don't want seafloor topography, we want dynamic topography. There we go. Okay, and I'm just going to overwrite that file, export. So now if I go git status again, we can see that I've made a modification to that file. And now if I want to commit that change, I'll just go git add Dietmar and Joe, and then git commit, and I'm going to do -m so I can append a little message to that commit. I'm going to say dynamic topography. There we go. So it says that that file's been rewritten. Now that's just on my local repository. If I go git push origin master, then it'll push it to the GitHub repo, so that if I click on code, I can see in the latest commit tag, there's dynamic topography next to that file. And again, we can compare those changes. Let's go history, and then say, oops, I pressed the wrong button. I press back. Yeah, display the rich diff. Yeah, there it is again. Yeah, here we go. That's the right commit tag. So no dynamic topography, dynamic topography, no dynamic topography, dynamic topography. So that's pretty much all I wanted to show you guys for now. What we can do later is do an example with continuous integration, where we can integrate a whole bunch of tests and benchmarks into our workflows, so that we can see that if we're making some commits to a repository, that those changes aren't going to break existing functionality in the repo. And for that, I'll focus on some Python workflows with GitHub Actions. But yeah, I think that's a good place to stop.
That was awesome. Thanks so much, guys. Absolutely brilliant.
Cheers, Sabine.
Good to know.
Well, if there's no more questions, then
I just wanted to add one thing. So the document that Michael had started circulating with, a collection of examples of problems or how to solve them, or GitHub actions. Mm-hmm. If that could be further populated, so that there is, because not everybody is going to remember how to do all of this, especially if you don't do it for some time. So if there's a document, a cheat sheet that you can go back to and say, okay, how did we do this again? And just look up individual.
Yeah, that makes
cases.
sense. Also, the next code clinic is on the, when did Julian say, the 29th? So we can maybe continue some of the, or we can start on the continuous integration workflows there.
Yep, and perhaps meet these questions too.
Yeah, I think a document like this is going to be really crucial, because that's what we have in the SVN at the moment. So anybody can really just pick it up and run with it. So if we have something equivalent for GitHub, would be good.
Yeah, the new research assistants can pick it up this way.